Bismillahirrahmanirrahim. I am Dr. Syed Azhar. In this lecture of linear algebra, we will study vector spaces. The definition of a vector space is, let V be a non-empty set such that V will be closed with respect to addition and scalar multiplication, and later on this non-empty set V will satisfy all these 8 results. In the first, this non-empty set V will satisfy an associative property with respect to addition, and in the second property, this non-empty set will have a zero vector. If we add that zero vector with any vector u from left side or either from right side, we will get the same vector v. In the third condition, there will exist a negative vector for each vector, that is minus u for vector u, such that if we add that negative vector from left side with original vector u or from right side with original vector u, we will get a zero vector. And in the fourth property, this non-empty set will satisfy a commutative property with respect to addition. In the fifth property, scalar k into u plus v will gives you k times u vector plus k times v vector. And for scalars a and b, a plus b into u vector will gives you a times u vector plus b times u vector. In the seventh property, ab into vector will gives you a times b times vector u. And in the last property, there will exist a unit scalar such that unit times any vector u will gives you u vector. Example, show that V is equal to R square is a vector space, and this R square is closed with respect to vector addition and scalar multiplication. So to show that R square is a vector space, first of all we have to take any three vectors u, v and w. Since R square is basically R cross R, and its vectors are just like ordered pairs, and the components of each ordered pair are real numbers. So that's why u consists of two components, w consists of two components, and v consists of two components, as u, v, w belongs to R square. And we take any scalars a, b, c, r, a, b and k. In the first property, we have to check this associative property. But for this, since these components of u, v and w are real numbers, and we know that real numbers satisfy associative property, so that's why, since the components of vectors are real numbers, so it will satisfy the associative property with respect to addition. That's our first condition. Second one, since R square is basically xy plane, so this one is our x-axis and this one is our y-axis. What about this point? This point is known as origin, and its components are 0, 0. And this point belongs to this xy plane. So that's why, since 0 is equal to 0, 0 belongs to R square, and for any vector u, u plus 0 or 0 plus u will gives you the same vector u. In the third condition, look at the same xy plane. If I take here 2, 3, then what about minus 2 and minus 3? So the negative of this point will lie in the third quadrant. If I take here AB, then its negative will lie in the third quadrant. If we take any point CD in the second quadrant, its negative will lie in the fourth quadrant, and vice versa. The negative of a point in the fourth quadrant will lie in the second quadrant, and the negative of a point in third quadrant will lie in the first quadrant. So this shows that there exists negative vector for each vector u, such that u plus negative u is equal to negative u plus u will gives you 0. Why? The negative of 2, 3 is minus 2, 3. Now add these 2 points, 2, 3 plus minus 2 minus 3. This will give you 2 minus 2, 3 minus 3 will gives you 0 and 0. That's why we said that this will gives you a 0 vector. In the fourth property, just like first property, since the components of each vector belongs to real numbers, and we know that real numbers satisfy commutative property, so these vectors will also satisfy commutative property. These are the first 4 conditions which are satisfied by this V. Now the fifth property is k times into u plus v is equal to k times u plus k times v. Take left hand side. K times u plus v is equal to k times u vector is basically u1, u2, and v vector is v1, v2. Now add these two vectors. You will get u1 plus v1, u2 plus u2. Now multiply this k with both components. So it will gives you k times u1 plus k times v1, comma k times u2 plus k times v2. Now take this right side. Right side is k times u plus k times v. U vector is basically u1, u2, and v vector is v1, v2. First of all, multiply this scalar with both components u1 and u2. You will get ku1, ku2. In the same fashion, from this you will get kv1, kv2. Now add these two vectors. You will get ku1 plus kv1 and ku2 plus kv3. Now compare these two results. So both are same. This shows that left hand side is equal to right hand side. So this property hold in this set V. Now the sixth property is a plus b into u vector is equal to a times u plus b times u. Just like fifth one, take left side. Left side is equal to a plus b into u. Put the vector u, which is u1 and u2. Now multiply a plus b with u1 and u2. You will get a plus b into u1, a plus b into u2. Since we know that a, b are scalars, u1 and u2 are also real numbers, so we can multiply them. So this will give you au1 plus bu1, au2 plus bu2. Now add these two vectors. So this is our left side. Now take right side, au plus bu. Put the vector u, which is u1, u2. Now multiply a with u1 and u2. We will get au1 comma au2. Similarly, multiply b with u1 and u2. We get bu1, bu2. Now add these two vectors. We get au1 plus bu1 and au2 plus bu2. Now check these results of left side and right side. Both are same. So this implies that left hand side is equal to right hand side, and this sixth property hold. Now the seventh property is ab into u vector is equal to a into b u vector. Take left side, ab into u vector. U vector is basically u1, u2. Now multiply this ab with u1 and u2. Since we know that a and b are scalars, so the product of a and b will also be a scalar. Now look at these components. We know that a is a scalar, b is a scalar, means real numbers. and we know that u1 and u2 are also real numbers, and real numbers hold the associative property with respect to multiplication also. So these number will also satisfy associative property with respect to multiplication. So this can be written as a into bu1, a into bu2. Take a common, we get bu1, bu2 in the components, and this can be written as a times bu, which is the right side of seventh property. This shows that left side is equal to right hand side. Now eighth property, since 1 can be written as 1 0, since actually in the xy plane this point is basically 1 0, so that's why 1 belongs to r square, and we can write 1 into any vector u, that will gives you the same vector u. So it means that this non-empty set which was closed with respect to vector addition and scalar multiplication also satisfies all the 8 condition of a vector space. So this v is equal to r square hold all the properties of the vector space, hence v is equal to r square is also a vector space. You can check it, v is equal to r cube, r4, and so on. This is the end of today's lecture. Feel free and ask questions. Thank you.